All right, 3.3, solving systems by elimination. So just like before, I mentioned that we could solve multiple ways. We've done graphing, we've done substitution. So now we want to look at our third method, not our final method, but our third method for these at this time is elimination. We'll look later on at a different one in chapter 10, but that's just a different concept for those pieces. Okay, so let's focus in on elimination here today. So we're going to hop right into our examples. I'm going to do some circles right here in the front of the room real quick, trying to find my paper. Here we go. All right, let's look at our examples. And we, again, are going to be solving. So 9x plus 5y equals 6. 2x minus 5y equals negative 17. All right, now our goal is the same thing. So again, these are all different methods. We are looking for an ordered pair that works for both these equations. And so when we use the elimination method, we are looking for certain pieces. We are looking to see, do my two equations have the variable with the same number but different signs in front of it? So for instance, here in example 1, I have y that has a positive 5 and a negative 5. And that's what I want. Now, if we don't have that, we can create it. And I'll show you that in just a little bit when we have those pieces. But here it already happens. And what this allows us to do, because of equality, what we can do here is we can add these two things together, keeping the signs that they are, okay, for those. Okay, so here, let's do this. 9 plus 2, that's 11x. Positive 5 plus a negative 5, that kill each other, which is what we want. We're wanting something to eliminate, okay? Equals 6 and negative 17 give us negative 11. Now, the reason why we want to do that is now in blue, I have equation 11x equals negative 11, and I can solve for x. So let's do that. We divide by 11, so x equals negative 1. Okay, so there's my first part of my solution. I have my x value just that fast. Now we can take and plug that in. It doesn't matter which equation, just go back to your originals. I'm going to go to the top one, so I'm going to plug this in right up here. And so we get 9 times negative 1 plus 5y equals 6. So that gives me negative 9 plus 5 equals 6. 5y equals 6. I'm going to add the 9 over. 5y equals 15. We divide, so y equals 3. And so there are my two letters. So we put it together. That's negative 1 and 3 for my solution. I should be able to plug this into both equations and get the correct answer for that it is a solution. Okay? Right. 2, we have 5x plus 3y equals negative 11. And then 3x minus y equals negative 1. Now, you do want to make sure that when you're doing these, that you do have them lined up x, y, and then a number. So we have that here, x, y, and a number, because we're going to look for things to eliminate for us and be able to do those pieces, all right? So here, when we look at this one, we see that we do have our x, our y, and 11, but nothing is the same. So we want to make something the same, all right? Now we try to make our lives easier. Here, if I try to get the x's to be the same, I'm going to have to multiply both of them because 3 does not go into 5 evenly. But here on the y's, 1 does go into 3 evenly. So to make these the same, I'm going to multiply this equation by 3. Okay? So I'm going to do this over here to the side. So my top equation hasn't changed. 5x plus 3y equals negative 11. But my bottom one is now 9x minus 3y equals negative 3. So by multiplying, because I can do that as long as I multiply everything in the equation by that number, it creates just a multiple of it. It's the same equation. Well, we see that my y's are going to cancel. So 5x plus 9x, that's 14x, negative 11 and negative 3, make negative 14. So we divide there, and x equals negative 1. Now, I do always recommend that you plug back into your originals. So one of these in blue, doesn't matter which one. So I'm going to plug into the bottom one. They're just kind of smaller numbers. It's okay. It doesn't matter which one you do. Okay. I change from time to time. So that tells me that we get 3 times negative 1 minus y equals negative 1. So negative 3 minus y equals negative 1. I'm going to add the 3 over to get negative y equals 2. So y equals negative 2. So we have our two answers. You have negative 1 and negative 2. Okay. So now you can see we can start making these things the same by multiplication, so that we can then do our elimination. Right, let's see what our next one is. Number 3. So 3x plus 2y equals 24, and 2x plus 3y equals 26. All right, so this time I'm looking, 2 does not go into 3, 2 does not go into 3. So we are going to have to multiply both equations, and that's okay. We do that from time to time. And so let's look at how we're going to do this. Now, it does not matter which variable you eliminate. The first two problems, it happen to be y. I can eliminate x as well. So I'm going to do that here so that you can see we can do either one of the variables, whichever one you see. All right, so the easy way when we're having to eliminate in both, if I'm looking at x, is I'm going to take this 2, I'm going to put it up here. Take this 3 and put it down there. But we do have one more problem here. If I multiply them as they are right now on the board, I would get positive 6 and positive 6, which do not eliminate. So I need one of them to be negative in order for it to do that. So we need to multiply by a negative. And I'm going to do the top one. It does not matter which one. You can do the bottom, but only do one. All right, so let's do that to the side here. So negative 2 times 3 is negative 6x. Negative 2 times 2 is a negative 4y. Negative 2 times 24 is a negative 48. All right, 3 times 2 is 6. 3 times 3 is 9. 3 times 26 is 78. Okay, let me verify that. Doing that in my head real quick. Yeah, there we go. I had to check my answer sheet just to make sure. So I'm not using a calculator. Now we can put those together. So those go together, cancel out. Negative 4 plus 9 is 5y. Negative 48 and 78 give me 30. So now we can divide. So y equals 6. Well, again, we can plug it into either one of the two equations. I'm going to go with the top one up here. So I'm going to take this and I'm going to plug back in up here. So 3x plus 2 times 6 equals 24. So 3x plus 12 equals 24. I subtract 12 from 24. So 3x equals 12. So x equals 4. So we get the solution for 6. Okay. Number 4. 2x plus 3y equals 1. 4x plus 6y equals 2. All right, so when we look here, 2 does go into 4, 3 does go into 6, so we can eliminate either one of those. I want to do the x again just to show we can eliminate that x. So 2 goes into 4 twice, but they're the same sign, so I need to do -2. So I need one of them to be negative and one to be positive. All right, so 2 and -2 give me -4x. 2 and 3 give me -6y. -2 and 1 give me -2. And then I bring over the bottom one. Okay. All right, now here, these eliminate. Well, these happen to eliminate, and so do these. So that means 0 equals 0. Okay, we have to have a statement under there. Yes, they're all canceling out, but there's an equal. So if I start with an equals, I must end with an equals. And so when things eliminate, we're actually making zeros. So we need that to read 0 equals 0. Well, that's true. We talked about that before. So that is infinitely many solutions. Okay, so if everything eliminates and I get 0 equals 0, that means that we have infinitely many solutions. Right, number 5. X minus y equals 5. 4x minus 4y equals 6. All right, so I'm going to eliminate y this time. So here I need to get to a 4. So I'm going to multiply by 4, but again, these are the same sign. I need to change, so I need to multiply by -4. Now, do expect to see this work. Some of you may be able to look at those equations right now and know the answer. I expect you to show me work. You need to show me the elimination for that. So -4 times x is -4x. -4 times y is a +4y. -4 times 5 is a -20. And then the other one comes on down. All right, now our x's and our y's do eliminate. We see their opposite signs, but that's 0 equals -20 and 6, though, give me -14, not 0. So these are not true. 0 does not equal -14, so that is no solution. Okay, so these are the different styles of eliminations. We're trying to make those letters the same. Make sure that they have different signs, though, so that's where that negative may come into play, so that things eliminate and we can solve for those answers, right? So that's that third method. So you have graphing, substitution, and elimination methods to be able to solve your equations with, or your systems with.